So we're going to discuss amplitude and period as it relates to sine and cosine functions. So first, just to define amplitude. So this is considered to be half the difference between the minimum and maximum values, meaning y values. So this really describes the height of the graph, and I think it's easiest to understand this with graphs. So we're going to take a field trip to Desmos.com. So here we are at Desmos.com, and so I'm going to be able to really quickly show you what amplitude means. So this black dotted line is going to be the graph of sine of x. So I highly recommend, if you're learning this for the first time, that you draw a little baseline sketch. It doesn't have to be anything like super detailed, just something to kind of set your baseline that this is what sine of x is. And now let's compare that to 2 sine x so you can see what amplitude is. So 2 sine x is this blue line, and you can see that it's quite a bit higher or lower than the black dotted line. So I want to point out something kind of key here. So this peak, the peak that we hit on sine of x, this hits a peak of 1. That is the highest y value that sine hits. But this other function, so this blue function, notice I have a 2 multiplied in front of it, and 2 is the highest y value that it hits. And then similarly, the lowest y value that sine of x gets to is -1. But on the blue function, the lowest y value that it gets to is -2. So this 2 will alter that ultimate height that sine achieves. So that's what amplitude is. Okay, so I would recommend that you just have like a sketch to kind of show yourself how that 2 changed sine of x. So draw a little sketch so that you remember that. And now I want to compare that to half sine x. So let me turn off 2 sine x, and now I'm going to turn on half sine x, which is the red line. And you can see now that this is like a shallower graph, right, than sine of x. And if I look at, so where does this graph bottom out? So it bottoms out at -1/2, and its new height is 0.5. So this 1/2 now dictates the highest and lowest points that sine of x reaches. So again, if you're learning this for the first time, I think a really helpful way to remember this is to just draw some sketches so that you can see how these things compare. And if you want to just see all 3 together, so there they are. Okay, so that's what happens with sine. Let's compare amplitude now for cosine. So let me switch all these graphs. So, you know, we're like scientists in some ways here, so we want to just kind of experiment and see if the same thing happens with cosine. So now my black dotted line is cosine, okay? So let's see what happens with 2 cosine x. So same thing, right? So let's see, I'll actually zoom out a little bit here. Okay, so now my cosine had kind of the same thing. It hits the x and y axis at different points, right? But the highest and lowest points of cosine were 1 and -1. And now by multiplying by 2, that same thing that happens, right? So now 2 is the highest point and -2 is the highest point. So this 2 is doing the same thing that it did to the sine function. So again, just to help you remember it, I think it's always helpful to have little sketches so that you know how to interpret these numbers in kind of an informal way so that you remember. Okay, so let's just compare that to 1/2 cosine. So let's see, 1/2, same thing, right? So now it's a shallower graph, and if I just look at where it's bottoming out at, it's now bottoming out at 1/2 and +1/2. So that's what amplitude does. Okay, so let's address one other thing. So let's say that I have my amplitude is something negative. So let's get rid of this graph. And so let's do, how about just negative cosine of x? So now the blue line represents negative cosine of x. So what ends up happening? Remember, the black line here is regular cosine, and the blue line now is negative cosine of x. So where I used to have on the original function 1, I just want you to notice now it has the point 0, -1. So it literally flips the whole cosine function. That's what putting a negative in front of cosine does. So that's still considered to be amplitude. That would be an amplitude of -1, but the impact that it has is that it flips the whole graph. Okay, and maybe just for funsies here, I will multiply by -2 just to see what happens. And so it's the same thing, right? It still has that same impact with amplitude. Now the lowest and highest points that it gets to is 2 and -2, and it flips the whole graph. So that's what happens with amplitude. So just to be clear, if your function is of the form either a times sine of x or a times cosine of x, the absolute value of a will give the amplitude, and then if a is negative, we also know that that will force the graph to flip. So that's just a little summary. So now let's talk about period. Period is the least value for which the function will repeat itself. And again, I think the easiest way to view this is with another field trip. So let's go back to Desmos. So when we refer to period, we're actually referring to doing something to the x. So we're going to compare sine of x, sine of 2x, and sine of 1/2 x to understand period. So once again, I would recommend that you just have like a little base sketch to show, sine of x. And now let's see what happens if I multiply that x by 2. So what ends up happening? Maybe I need to zoom in a little bit here. So it looks like now we still have the sine function, but it like is waving faster, right? So the period, in some ways, we're thinking it gets a little tighter or it gets a little faster. The waves kind of go through faster. So this is kind of the idea behind period. And this is a little bit trickier to graph, so I will break down how to graph this for you in a few minutes. I just want to get you an intuitive sense of what it is. Okay, so let me back out. Now let's see what happens with sine of 1/2 x. So again, I would just draw like 2 sketches if I were you, and in both have kind of sine of x as your starting graph, and then draw over it maybe the comparison graph. So let's take a look at sine of 1/2 x. Okay, so now what do you see? So now, in comparison to sine of 1/2 x, it's still waving, right? It's just going much more slowly, maybe, if you want to think of it like visually. So it still waves through, it just goes through, and it's like more elongated for sine. So that's what period does. Let's just compare what happens with cosine of x just to see if this is the same. So let me switch these functions. So now I've switched to cosine. So again, just have kind of your starting graph. This is where we're going to compare everything to. So now if I have cosine of 2x, does the same thing happen? So yes, the same thing happens just like it did with sine. So our waves are going much faster. And then if I want to compare cosine of 1/2 x, so let's just see. And now I can see the waves are still going much slower. So we can see that period works the same with sine and cosine. So now we've just got to figure out how do we actually work with this or graph it. So the first thing that I want to tell you with period to help us get to graphing it is how to actually figure out what the period is. So if you have a formula, or if you have a function sine of bx or sine of cosine of bx, you have this number next to x. To figure out what the period is, you use this formula, 2 pi divided by b. So the first thing that I want to do is I just want to get you used to finding the period. So I've got a couple of examples here. So let's start with sine of 3x. So in this case, so you're just looking for that number that's attached to x. So in this case, I'm going to consider my b equal to 3. And now I have to do a little bit of work to figure out what the period is. So I use this formula, 2 pi divided by b, and I plug in for b that 3. So put 2 pi divided by 3 is the period. 2 pi divided by 3 is a tongue twister for some reason. Okay, so here's the period in this case. That's all I need to know for right now. So let's try this again with b. So what's my b in this case? It's 1/2. So I'm going to plug in 1/2 for b. So if I do that, 2 pi divided by 1/2, this is going to just take a little bit of algebra to figure this out. So I have 2 pi divided by 1/2. That's equivalent to 2 pi times 2, which is going to equal 4 pi. So 4 pi is the period. Okay, so maybe you just want to pause for a second and think about what is the period for C. You can hit play when you're ready. So for C, my B in this case is all of 2 pi. So 2 pi divided by 2 pi comes out to 1. So 1 would be the period in this case. Okay, so that's a key thing that we need to be able to do for graphing. So I want to just summarize what we've learned so far before we start graphing. So I can have either a times sine of bx or a times cosine of bx. And in this case, the amplitude is found by taking the absolute value of whatever our a is. And then the period is found by taking 2 pi divided by b. So what we're going to do in the next few examples is we're going to graph over 2 period intervals, and then we want to identify the amplitude and period. And I'm going to break down kind of everything about this process for you. Okay, so starting with the first example. So I've got y equals cosine of 1/3 x. So first things first, let's figure out the period and the amplitude. Okay, so the period, remember, we're going to use that 2 pi divided by 1/3. So 1/3 was my b, so I'm just going to plug this in, and then I've got to just work out the algebra. The algebra is going to work out to 2 pi times 3, so this will equal 6 pi. Okay, so there's my period, and then my amplitude, I've got no number in front here, so I'm just going to say that my amplitude is equal to 1. Okay, so the period is pretty important for helping you figure out how to graph. If you don't use the period, you're going to make graphing a lot harder. So this will determine really how to set up the table. So to do this with our period of 6 pi, what we want to do first is we want to start at 0. We always start our tables at 0. And then we want to divide the period into 4 equal length intervals. So what do I mean by that? What I'm going to do is I'm going to take 6 pi and divide it by 4. And when I divide this, this is going to give me the first table entry, and then it's also going to tell me the steps that I want to take on my table. So I'll show you what I mean by that in a second. And then this really ultimately will help us to choose the x's in our table. So like I said, we're going to start at 0. So when you have just a problem like this, 0 is going to be the easiest place to start. And if I plug in 0, I get 1. And then I'm going to start using my steps. So that 3 pi over 2, that's the first table entry that I want to make. And then I want to make my next table entry. So I take this number and then I add another 3 pi over 2 to it. And that's going to give me 3 pi, okay? Now to get to the next entry in my table, I'm going to add another 3 pi over 2. So you see what I mean by steps? And that gives me 9 pi over 2. So I'm going to put that in the table. And then from 9 pi over 2, I'm going to add another 3 pi over 2 to get 6 pi. And then I always like to do one extra entry. So like if you, some books or some explanations are to just do these 5 steps. I like doing one extra step because it helps me feel confident that I did this right. And it's like a check for my math. So I add another 3 pi over 2 to this to get 15 pi over 2. Okay, so here's my table. And you're going to see why this makes life so much easier as we go through a few examples. So you'll start to get a sense of this as we go through these examples. So now what we need to do is we need to calculate y. Okay, so let's just bust out the table here for a moment and let's make some space for this. So I need to plug in 3 pi over 2 into this function here. So I've got y 1/3 times 3 pi over 2. So if I work all this out, I see that the 3's drop out and really I'm just left with cosine of pi over 2. And that equals 0, so I can plug that into my table. So next I'm going to move on to 3 pi. So let's go ahead and plug that in. So I've got cosine of 1/3 times 3 pi. This comes out to cosine of pi, and this will come out to -1. So I want you to notice something. You're going to notice this emerging pattern. We're kind of like gaming our entries in some ways so that we are cycling through like pi over 2, pi, 3 pi over 2, 2 pi. As you continue to work through this, you're going to notice like we make strategic choices with these x's so that our math works out like this so that we're getting these y entries. So I'm just pointing this out to you now. I want you to notice this as we do more examples. Okay, so moving on to 9 pi over 2. So if I plug that in, so notice this gives me cosine of 3 pi over 2 when I simplify, and so that's just going to equal 0 again. And so you can fill in the last 2 entries. You can pause the video here if you want, and you can go ahead and calculate these last 2. I recommend that you do that. And if I do that, I should get 1 and 0. Okay, so now I have my table set up, so I'm good to go. A couple of things I want to point out with this. First of all, from here to here, I want you to notice like from here to here, this is considered one period, and notice that goes from 0 to 6 pi. That is what we said that the period was, right? So we can actually see this. And what I want you to notice is like, we start the interval kind of back over of this 1, 0, -1, 0. You can see this interval restarting here. So it's restarting at 1, 0. The next entry would be -1, 0. So there's like this pattern that gets established here. So you can always tell if you did this right if you can identify this period like this. So this will be a consistent thing. Note the rises and the falls with these graphs. So we've got this 1, 0, -1, 0, 1. So that is a really common pattern that you're going to notice over and over between cosine and sine as you continue to graph more and more of these. All right, so now I need to set my axes. So you're going to have to draw your own graph. And I like to set, so I like to come up with a scale based off of, after I create my table. So now I am going in 3 pi, 6 pi, 9 pi, 12 pi, whatever, and then the highest and lowest here is 1 because that's what's in my table. And then, and I would recommend that you do this as well, I would take a moment to just plot all the points that we have in our table, so on your graph. So, math is not a spectator sport. I recommend that you do this also on your own. You'll get more out of the video if you pause and just try to make sure you're up to this point. And then I can connect everything. And that's the wave that we're looking for, right? And okay, so cool. I have part of my cosine graph, and I want to point something out now in the graph, so just visually. So from here to here, this peak to this peak, this is one period. From here on out, this period is starting over again. And we were told in the directions that we need 2 periods. So what I can do, once I kind of establish this pattern, I can just continue the pattern. So I can continue the pattern like this. And so I'm literally just continuing the pattern that I had before, and I connect everything. And so there we go. We've got the graph. Now, remember, I was a little strategic in how I set up my scale. So I just want to show you real quick what the actual graph, like if you were to go to Desmos, what that looks like. So because of how I set up my scale, like, and you'll notice just the way I set up my scale, my graphs are going to look different from Desmos. But as far as like where we see the peaks and valleys, so notice I've got -3 pi, -1. That was a point, or that should be a point. If I were to continue my graph, that would be a point that I would have found. I've got -3 pi over 2. So let's see, let's go over to this side. These are some of the points that we found on our table. So, okay, so this is 0, 1. We found that point. 3 pi over 2 over 0, and then 3 pi -1. So these are all points that we just found, right? So if you were to compare this, like when you mess with your scale a little bit, your graph could look different. So just keep that in mind. We're kind of gaming our axes a little bit, but we do have the right graph. Now, the other thing that I want to point out here is that our directions said that we just had to graph over a 2-period interval, so I have fulfilled those directions. I could have technically gone this way, as you just saw in Desmos, so we can also go in the negative direction, but our directions just said 2-period interval, so I'll just stick with that. But I'll show you, I'll show you in the next example how to continue if you wanted to do that. So let's take a look at the next example, 2 sine x. Okay, so first things first, so we got to discuss period and amplitude. Now, if you feel like you've got that, I would recommend that you pause and just write those down before we get started. So the period in this case is going to be 2 pi divided by 1, which is just 2 pi. So that's the standard period. And then the amplitude in this case is going to be 2. So as far as what you do with period, so I always want you to think about dividing your period into 4 parts. So 2 pi divided by 4 will come out to pi over 2. And again, this is going to be what motivates how we fill in our table. So if I come back here, so I want to start at 0, but then the next point that I want to fill in is what I found from my division, so pi over 2. And then I can just keep adding on. So if I add pi over 2 over to that, I get pi. And then if I add another pi over 2, I get 3 pi over 2, and then 2 pi, 5 pi over 2. So here I am making all my little steps. And now I can go through and I can take the time to calculate these, okay? So at 0, I just get 0, so that one's the easy one. So next, let's plug in pi over 2. So for pi over 2, I have 2 sine pi over 2. Now, sine of pi over 2 is equal to 1. So 2 times 1 is going to be equal to 2, so that's going to be the entry that I put in the table. So let's do this again for pi. So 2 sine pi. So sine of pi is 0, so this will just equal 0. So I would recommend that you pause the video and try to just fill in the rest of the table to make sure that you've got this and that you're finding the right points. And then you can hit play when you're ready. So if I plug in 2 sine 3 pi over 2, so that'll come out to 2 times -1, which just equals -2. And then my last 2 points, 0 and 2. So you can see that pattern starting over again. So coming back to what we were just working on, so I want to point out one more time, I can see from here to here, this is 1 period, and then I can see the repeat starting here again. And I can see I'm going from 0 to 2 pi. So I can see how that period is kind of working itself out. Okay, so now I need to set up my axes. So in this case, I'm going to go in intervals of pi. I think that'll just be easiest. And then notice I've got 1, 2 tick marks for my y's. And from here, I can go ahead and just plot all my points. So you can go ahead and plot all your points as well. So feel free, if you're playing along at home here, always feel free to pause the video. I always think this is far more meaningful if you're actually taking notes and you're writing stuff down and you're making sure that this actually makes sense to you. Okay, so I've got all my I've got all my points plotted, and okay, so I connect them, and so from here to here, this is 1 period. So just make sure that you understand the difference between 1 period for sine and 1 period for cosine. They're slightly different in how they look. Okay, and so now what I'm going to do is I'm just going to extend this. I'm going to continue the pattern with my points and connect them. So now I've got 2 periods. So this would technically be 2 periods, but like I said, you can also go into the negative if you want to get just 2 periods going that way. And it's the same thing. Once you establish that pattern with your points, you could just kind of continue that pattern like you see me doing here. And so here would be another period. So I've got that high, I've got that low, so we're good to go here. So, okay, that's how to do this example. So I've got one more example, and now I'm putting everything together. So we've got both amplitude and period to mess with. I would highly recommend, if you've been watching this, that you try this one totally on your own. Try to come up with the table, period, amplitude, everything, and then hit play when you are ready. And this, you'll get a lot more out of this video if you are trying it on your own. Okay, so let's first talk about period and amplitude. So the period in this case is going to be 2 pi divided by 2 pi, so the period is 1, the amplitude is 3. We can see the 3 right here. And so for my steps, I need to take 1 divided by 4, so my steps will be just 1/4. So as I fill in my table, of course I start at 0, and then I'm going to go 1/4, 1/2, 3/4, 1, and 5/4. So those are my steps. And so now I want to just take a moment to plug everything in and just see if I'm getting this. So at 0, this comes out to 3. So make sure you don't forget about the 3 in front. That's a really easy thing to forget. And then as I plug in some of these points, so 3 cosine 2 pi times 1/4, so that will simplify to 3 cosine pi over 2. So again, notice how we're just always cycling kind of through these pi over 2, pi, 3 pi over 2, etc. That's kind of like what we're doing when we choose some of these x points. Okay, so anyways, so 3 cosine of pi over 2 is just 0, so this is 0. And then if I do 1/2, so 3 cosine 2 pi times 1/2, this will come out to 3 cosine of pi, so this comes out to -3 times 1, so this just equals -3. And to fill in the rest of my table, I've got 0, 3, and 0. So I'm going to just assume that you kind of know how to get through the math on that. So I've got my table here. And so from here, I can see that once again, we've got that period of 1. So I can see that the table is restarting itself after the 3. So we restart the period. And I can see I'm going from 0 to 1. So there's my 1 period. And then I can go ahead and I can label my axes. And so I've got 1, 2, 3 tick marks for my y's. I'm going to go in 1/2 intervals in this case. And so now I can plot my points, bada bing, and then I can continue the points to get the other part of this. And so there would be the graph once again. And you could make that comparison to Desmos.com if you just wanted to see if you got the same peaks and valleys. And okay, so that is really an explanation of period and amplitude. So if you found that helpful, consider leaving a like for this video or a comment, sharing with your friends, or subscribing to the channel. And otherwise, thanks for watching, guys. I'll catch you in the next video.